Chips. Tiny slices of silicon, barely thicker than a fingernail. But in 2025, they are no longer just parts of your phone or computer. They are the front lines of a global war, a technological arms race that's reshaping geopolitics, reshuffling power, and redefining who controls the future of artificial intelligence. At the center of it all, a handful of companies like NVIDIA, AMD, and Intel, and one rapidly escalating conflict between the United States and China. If you've ever wondered why AI is moving so fast, or who's really controlling it, this story is going to blow your mind. But before we dig in, make sure to like this video and subscribe to the channel. We break down the world's most complex tech stories and turn them into something you can actually understand. Let's start with the name on everyone's lips, NVIDIA. In just a few years, NVIDIA went from being the company behind your gaming graphics card to becoming the crown jewel of the AI revolution. Their chips, especially the A100 and the newer H100 models, are now essential to training and running large AI models like ChatGPT, Google Gemini, and Meta's Llama. Why? Because AI requires massive parallel computing power, and NVIDIA's graphics processing units, or GPUs, are designed to handle exactly that. The company's data center business is now booming, and in 2024 alone, they pulled in over $50 billion in revenue just from selling chips for AI. But it's not just about speed, it's about control. The company that builds the most advanced chips holds the keys to AI, and that makes NVIDIA's hardware a matter of national security. In response, the US government began taking aggressive action. In 2022, they issued export restrictions on NVIDIA's most powerful chips, banning their sale to China. The reason? Fear that Chinese companies, backed by Beijing, would use these chips to train military-grade AI or build surveillance supercomputers. At first, NVIDIA worked around it. They released modified versions of their chips, the A800 and H800, designed to comply with US regulations, but still powerful enough to sell in the Chinese market. But Washington pushed back. In late 2023, the Biden administration tightened the ban, cutting off not just the high-end chips but also the lower-tier ones. This wasn't just a trade decision, it was a declaration of technological containment, and China didn't sit back. In retaliation, they restricted exports of gallium and germanium, two rare minerals critical to making semiconductors. Suddenly, the chip war wasn't just about money. It was about raw materials, global supply chains, and the fragility of an industry that powers everything from smartphones to satellites. The semiconductor Cold War had officially begun. Now enter AMD and Intel, two American giants with decades of chip-building experience. AMD, under the leadership of Lisa Su, has rapidly caught up to NVIDIA in raw performance. Their MI300X accelerator is a serious competitor to the H100, and is being adopted by companies like Microsoft for AI workloads. AMD's strength lies in its chiplet architecture, which makes it easier to scale performance without ballooning costs. Meanwhile, Intel has been reinventing itself. After years of falling behind, they're making a comeback with their Gaudi chips, designed specifically for AI training. And let's not forget Intel Foundry Services, a move to turn Intel into not just a chip designer, but a chip manufacturer for others. That's a big deal in a world that wants fewer dependencies on Asia. Because here's the elephant in the room. Most of the world's advanced chips are manufactured in just one place, Taiwan. Specifically, by a company called TSMC, or Taiwan Semiconductor Manufacturing Company. TSMC produces chips for Apple, NVIDIA, AMD, and many others. Their fabs are the most advanced on Earth, and Taiwan's location, just off the coast of China, makes the situation even more tense. If geopolitical tensions ever erupted into conflict, the entire global tech ecosystem could collapse overnight. That's why the US is investing billions into bringing semiconductor manufacturing back home. The CHIPS and Science Act, passed in 2022, allocates over $50 billion to domestic chip production. TSMC is building factories in Arizona. Intel is expanding in Ohio. Samsung is building in Texas. It's an arms race, not with bombs, but with wafers. But let's talk numbers. As of 2025, NVIDIA controls over 80% of the AI accelerator market. Their H100 chip costs more than $30,000 a piece, and data centers often buy them in racks of 8, 16, or even 32 units. Training a large AI model can cost tens of millions of dollars, and almost all of that money goes to compute. Microsoft, Google, Amazon, and Meta are spending billions annually just to rent access to these chips. Even OpenAI's most advanced models rely heavily on NVIDIA hardware. And that's where things get really interesting. Because the more centralized AI becomes, the more centralized power becomes. If only a few companies can afford the compute needed to build foundational models, they end up controlling the direction of AI development itself. And governments are watching. In January 2025, the European Union introduced a new AI sovereignty framework aimed at reducing dependence on US-made chips. Countries like France, Germany, and Japan are now investing in their own silicon startups. The goal? Build domestic alternatives to NVIDIA, because nobody wants to be locked out of the future. But here's a twist. China isn't giving up either. Despite the bans, Chinese tech giants like Huawei, Alibaba, and Baidu are developing their own chips, like Huawei's Ascend and Alibaba's Hangguang. They're not as powerful as NVIDIA's top-tier chips yet, but they're closing the gap. And with massive government support and a huge talent pool, China is determined to achieve chip independence by 2030. If they succeed, it could shift the balance of global AI leadership. At the same time, a quiet revolution is brewing in how chips are made. Startups are exploring alternative computing architectures like optical chips, neuromorphic chips, and even quantum accelerators. Companies like Cerebras are building massive wafer-scale engines, chips the size of dinner plates, that promise even greater performance for AI tasks. Others like Tenstorrent, founded by chip legend Jim Keller, are building open-source silicon to democratize access to compute. The next NVIDIA might not come from Silicon Valley. It might come from a garage in Toronto or a lab in Berlin. So where does this leave us? We're entering a world where chips are not just hardware, they are leverage. They determine who builds the next generation of AI, who wins the next economic race, who protects their data, and who gets left behind. This war over silicon is really a war over sovereignty. And unlike oil or gold, these resources aren't buried underground. They're designed, manufactured, and guarded by some of the smartest minds on Earth. And don't think this doesn't affect you. Every app you use, every search you make, every AI-generated answer you receive is powered by these chips. The shortage of GPUs means higher cloud costs, slower AI rollouts, and longer waits for innovation. And as compute becomes more valuable, it's not hard to imagine a future where access to AI isn't just expensive, it's political. In the next decade, we'll likely see national chip reserves, AI compute rationing, and even international treaties governing access to silicon. Because when the future runs on chips, whoever controls the chips controls the future. That's why this war isn't just between companies. It's between empires, between ideologies, between the old world and the one being built right now in clean rooms and code. Thanks for sticking with us on this deep dive into the chip war shaping our AI-powered world. If this episode opened your eyes, don't forget to keep in touch. We've got more stories coming soon about brain interfaces, robot factories, and the next wave of AI. See you in the next video.